Good afternoon, everyone. It's a pleasure to be here today at Ecosummit to present you Insolight and show you how we can feed citizens and the grid at the same time. So what are we talking about? Agrivoltaics. On one hand, you know that utility-scale deployments of solar require lots of land. On the other hand, you need to protect cultures from excess of sunlight and with plastic tunnels. You see here the plastic sea in Almeria. So the key goal of agrivoltaics is to combine both and use the solar modules as shading device for crops. If you just look at berries that need lots of shadings, which are a good use case, they represent 220,000 hectares in Europe only, and this is 300 gigawatt peak potential. So it's not a niche market as such. The problem is that conventional modules, as you all know, are opaque and they shade crops too much, degrading their yield. And therefore, they cannot be used as such on top of cultures. Here's our solution. It's called insolagrin. It's a translucent module that is covering the cultures and replacing the plastic tunnels, as you see here. This is one of our installations in Switzerland, in Conte, where we are based, 200 meters square on top of raspberries. And the goal is to demonstrate that we can maintain agricultural yield while generating electricity over the year. The key features is to be able to adjust the light conditions on the crops over seasons and over changing climatic conditions. So it's really like a shading device that is changing, for instance, depending on the weather conditions or on the fact that you have crops below. And the goal at the same time is all the light in excess can be used to generate electricity. You get very nice synergies because you have one infrastructure for dual purpose that you can monetize twice, once as an agronomic tool and a second time as a PV generator. How does it work? So, of course, there's a hardware behind. It's basically a standard PV modules that is paste wafers on which we add an optical layer made of glass. And this optical layer basically allows you to choose between sending light on the cells or next to them. And that's where the key innovation lies, is in the tracking. Basically, you can tune the light that is going through the module with this tracking and do lots of software layer on top to control the light for the crops. Coming to the business model, we are not a PV module manufacturer. As we said, we want to team up with global partners for the manufacturing and also for the installation. So our goal is to sell the modules and the software solutions to the solar developers that then can monetize two things: electricity, business as usual, but also the structure to the farmers to protect the cultures. And this is the key advantage of agrivoltaics, is to get this CapEx contribution thanks to the dual use of the structure. You know, in Switzerland, we like climbing. This is Eiger. This is the same in such kind of startup. We climbed every step, every ladder of the validations. With a very exciting milestones last year. We raised our Series A round, 5 million, and we launched this pre-series production, the first 1,000 modules that we are currently selling to key customers for pilots, utility companies such as Engie, Romand Energy. And the goal now is to scale up and, of course, raise more funds and also find global partners to build installations. This is how the financing looked in the past, mixed of equity and grants. The next step is to raise next year a Series B, main goal being to reach the megawatt peak scale deployments, and as well attract strategic investors that can help us scale, whereas it's greenhouse manufacturers, PV manufacturers, or solar developers. So very happy to be here today and discuss that with you tonight on both options. Thank you for your attention, and yeah, please join us to feed citizens and the grid.